Welcome to this explainer. We tend to treat our digital infrastructure like it's this impenetrable fortress, right? Guarded by the absolute brightest minds in the world. But today, we're unraveling a pretty terrifying piece of recent tech history. We're going to look at how a ridiculously minuscule script managed to hold the supposedly bulletproof Linux ecosystem hostage. I mean, what actually happens when an algorithm spots a crack that human experts missed for an entire decade? Let's dive into it.
So, Ubuntu, SUSE, Amazon Linux, and Red Hat walk into a bar. And out of nowhere, a 732-byte Python script penetrates the back door and beats them all to death with a baseball bat. Okay, it's a really dark joke from our source material, but honestly, it perfectly captures the downright absurd reality of this vulnerability. We're talking about tech giants that share what's widely considered to be bulletproof kernel code, and they were completely brought to their knees by the tiniest of weapons.
And seriously, the most staggering part of this whole exploit is the size of that weapon. 732 bytes. That's it. To put that into perspective, a standard text message on your phone is often larger than that. Yet that was literally all it took to completely bypass the defenses of the most ubiquitous operating system architecture on the planet. It wasn't some massive, sprawling, gigabyte-heavy piece of malware. It was just this tiny, incredibly precise script that knew exactly where to push.
Now, as you can imagine, the blast radius here was massive. Look at this list of affected distributions. It reads like a who's who of the server world. Ubuntu, SUSE, Amazon Linux, Red Hat, Debian, Arch. Basically, if you run a Linux server, or, if you're one of that rare breed running Linux on your desktop, and your kernel code was updated anytime since 2017, you were caught right in the crosshairs. We are talking about virtually every Linux machine on planet Earth.
And get this. This wasn't some sudden, flashy new break in the code. Tracing the timeline back is wild. Completely normal-looking commits were introduced to the Linux kernel way back between 2015 and 2017. And then, nothing. For nearly a decade, this 100% reliable logic flaw just sat there quietly, hiding right in plain sight. It wasn't until May 4th, 2026 that it was finally discovered, weaponized, and published. It got so bad that this vulnerability ended up notoriously sitting on CIS's known exploited vulnerabilities list, and CrowdStrike even confirmed it was being actively used in the wild.
So to really understand this weapon, we have to look at its technical definition. Officially, it was dubbed CopyFail and tracked as CVE 2026/31431. At its core, it's a vulnerability that allows an unprivileged local user to write 4 uncontrolled bytes into the page cache of literally any readable file, which ultimately grants them root access. This universal privilege escalation was considered such a massive, earth-shattering deal in the security community that it actually got its own dedicated website.
Let's do a quick step-by-step autopsy of how the exploit actually works under the hood. Step 1. The Linux kernel uses this thing called the AF_algit interface to expose kernel crypto algorithms to user space. Step 2. There's a weird bug in the splice function, something to do with an internal quirk involving extended sequence numbers, and it accidentally outputs 4 bytes of scratch data. Now, the fatal error happens in Step 3. That output buffer accidentally points straight into the page cache of a read-only file. So, Step 4, by pointing those specific 4 bytes into the read-only SU file, the attacker entirely owns the system. Just 4 bytes in the exact wrong place, and it's game over.
But honestly, the true mystery here isn't just the code itself. It's the terrifying revelation of exactly who, or actually, scratch that, exactly what, discovered this zero-day exploit. When the proof of concept first dropped, a lot of people thought it was just overblown slop. But then the Linux kernel team confirmed it. And here is the massive plot twist. No human hacker actually wrote this exploit. To understand the sheer gravity of this, you have to consider the stakes involved. According to CrowdFence bounty pricing, the gray market rate for a universal Linux privilege escalation of this caliber, it sits somewhere between $10,000 and $7 million. Just think about that for a second. This was a literal multi-million-dollar secret that had been sitting dormant right out in the open for 9 years. And yet it was uncovered in exactly 1 hour. That's it. An AI agent created by a company called Theory was given a super simple prompt about how that splice function handles page cache references of read-only files. In about 60 minutes of scan time, this AI-powered hacker found the logic flaw, wrote the exploit, and then Theory just dropped the multi-million-dollar proof of concept on the public internet for absolutely free. 1 hour for an AI to completely bork every Linux machine on Earth. It's wild.
Now, before you start unplugging your routers and panicking about the impending AI apocalypse, let's just clarify the actual threat level here. CopyFail is strictly a local exploit. That means attackers cannot magically breach your system from the outside using this bug alone. They have to have an existing foothold first, like a compromised application or existing SSH access, just to trigger it. So your personal Arch-based laptop sitting on your desk at home is probably safe, though obviously you should still patch it immediately.
You know, this whole situation perfectly encapsulates the modern developer's dilemma. AI giveth and AI taketh away. While an AI scanning tool almost single-handedly wrecked every server on Earth by exposing this critical flaw, AI coding agents are simultaneously emerging as the exact solution we need to write better code and prevent these kinds of disasters from making it into production in the first place.
So how do we fight fire with fire here? Well, the source material highlights defensive tools like CodeRabbit. Instead of running isolated, clunky security scans, these AI agents integrate directly into the developer workflows you're already using. Stuff like Slack, GitHub, and Sentry. If an issue pops up in a chat, the agent automatically pulls the relevant traces, finds the logic flaw, and literally opens a pull request with the fix without a human developer ever having to leave the chat. And even better, it records those decisions in the team's knowledge base so it actually gets smarter about your specific code base over time. This is how we ensure the highest quality code is written going forward.
Which brings us to the ultimate takeaway for today. A tiny 732-byte script paralyzed the absolute giants of the tech world, and it was completely orchestrated by an algorithm just doing an hour of homework. As we embrace these automated tools to both attack and defend our systems, it leaves us with a pretty chilling question. If an AI can uncover a 9-year-old, $7 million vulnerability in 60 minutes, what else is hiding in our code right now just waiting for tomorrow's algorithms to find? Thanks for joining me on this explainer, and hey, keep your systems patched